We begin with the question of whether f of 2 equals f of negative 2 for y equals f of x equals x squared, or x cubed, or the 2 to the x function. We can easily make tables and graphs for these functions. A table for y equals f of x equals x squared, using just x values, negative 2, negative 1, 0, 1, 2. Of course, you want the x equals 1/2 value in order to see a little more detail in the shape of the graph. But we're used to these now. We've been graphing these for a month, and we should be able to graph these very, very quickly and make these tables very, very quickly. And we know what happens at negative 1/2 and 1/2. So we draw our graph. Not a very good x-axis, but marking off equally spaced points for negative 1, negative 2, negative 1, 0, 1, 2, and then we'll indicate the point for x equals 1/2 because we pretty much know what goes here. We plot our points, and let's see, let's just take the y scale up to 4 here. So there's a reasonable y scale. So when x is negative 2, y is 4, and so forth. Now I'm not going to explain this as I graph it. Everybody should by this point be very adept at sketching this graph and should actually be able to make the table in their head. And we get our graph, our familiar graph, by now familiar graph. Now, we want to test whether f of 2 equals f of negative 2. Okay, well, we can do this in any number of ways. We could do it algebraically. F of 2 equals 2 squared, equals 4. F of negative 2 equals negative 2 squared, which is 4. So f of 2 does equal f of negative 2. We can see that from the table, of course. F of 2 is 4, and f of negative 2 is 4. So we just look at the table and see it. If the number we're checking happens to be on the table, we can look at the graph and see that it's true. Here's x equals 2. Here's x equals negative 2. To find f of 2 from the graph, we simply project up to the graph and over, and we find that our value is here. It's this point on the y-axis is the value f of 2. For negative 2, well, we do the same thing. We come up to the graph and we come over, and no surprise, if the graph is very accurate and if we've done our projections very accurately, we find that f of negative 2 occupies the same point on the y-axis. So by the graph, f of 2 equals f of negative 2. Okay, more generally, we could say that if we have any value of x, and let's just take a value of x here, and a value of x at an equal distance on the opposite side of the y-axis, we go over an equal distance and we get a point here. Okay, so we find the value of f of x. So this is our value x, this is our value negative x, right there on the axis. And we find f of x by projecting upward from this point and then projecting straight over. Okay, and we get a value here just a little more than 2 as I have it marked on the graph, but doesn't necessarily mean a whole lot. And if we project up to here and over, well, actually that projection comes out a little less than 2. But remember, I didn't draw particularly exemplary x-axis, it's sloped downward, there are uncertainties in the way I sketched this graph. So f of x would correspond to this value, f of negative x to this value. It might be a little ambiguous. I would say by the graph, f of x and f of negative x have very similar values, and they're plausibly equal. So it's very plausible that f of x equals f of negative x. Now we have a table over here, f of x equals f of negative x, and I can say that f of x equals f of negative x looks true. I can also go a little further than that. I can say, well, let's see. F of x equals f of negative x, question mark. Well, f of x equals x squared, and f of negative x equals negative x squared, which is equal to x squared, since a negative times a negative is a positive, so negative x times negative x is positive x squared. So algebraically, again, we see that it's true. So we can say here that f of x equals f of negative x equals x squared. Yep, it's true. And that's an algebraic proof. Okay, so from our graph, we see that f of x and f of negative x look like they might well be equal. The little discrepancy we have between these positions on the y-axis is just an anomaly of the process of graphing and drawing these projection lines. So we come to a pretty firm conclusion that f of x equals f of negative x. And of course, f of x then does not equal negative f of negative x, because the negative of f of negative x would be negative x squared. That would not be equal to f of x. So I could also say f of x not equal to negative f of negative x. X squared is not equal to negative x squared. Now let's be sure we understand that a negative x squared means we square x and then take the negative. If we want to square negative x, we have to put it in parentheses. This is the square of negative x, and that gives us x. But a negative x squared is a negative. It's the square of x with a negative in front. Okay. Well, anyhow, that's pretty much what we see for f of x equals x squared. Now, in the next clip, we'll take a look at f of x equals x cubed.